All right, today's 1/6, measures of center. A measure of center is a value that attempts to describe typical sets of data by identifying central positions of data. So the main thing that goes in there is just like a typical number that shows you what the data looks like. That's a measure of center. You've heard of all of these before from way back in the day. The first of the three, is if you add up all the numbers and divide by how many, that's called the mean. You know, a lot of people call it the average. So there's the mean, which is just like add them all up, divide by how many. I think we're pretty good at finding the mean. If you put all the numbers in order and found the one in the middle, that's called the median. Just like when you drive down the interstate, the median is that ditch between the two highways. So median is like the middle. And then the one that occurs the most is called the mode. Sometimes you could have two modes. That would be called bimodal. That's a weird word. You'll see that on homework a lot, that bimodal. Sometimes there's no mode. There's no number that occurs the most either. So mean, median, and mode, ways to measure center. So let's kind of check this guy out. Here it is. There's a dot plot at the left that shows the times of 20 different people in New York of how long it took them to get to work. They ask us, and this is how homework's going to work, to find and interpret the mean, the median, the mode. Guess what? I don't want to calculate any of that. I want the applet to calculate that for me. So on your computer, if you'd go to the applet, we've just got to enter in all of this data. So let me get there. What you'll have to do is here you're on the applets page. You'll have to go to one quantitative variable, single group, but see, it's not collaborative this time. The collaborative is only when we work together as a class to enter data. So click that dude right there, and if you would go into the data portion of this guy and just type all of those guys in. Let me get back to where we were. So you're right here, input the data separated by commas or spaces. So either put a space or not. So like the first one is 5, then the second one is 10. Then there is another 10, and then a 15, you know, like 4 different times there's a 15. So this is the hard part of just entering the data. I got too many 15s. So, and then a 20, and then a 20, and then a 20, and then a 25, etc. There's a 40, and a 40, and a 45, and a 60, and a 60, and a 65, and an 85. All right? And then once you get it all in there, you hit the Begin Analysis button right down here. Begin Analysis, and it'll give us those summary statistics. The first thing I check is if I typed in the right amount. You know, it told us in the problem that there was supposed to be 20 times. I got 20, so that is nice. So here's our summary statistics right here from that guy. They ask us to find and interpret the mean. First, what's the mean? What number is it? 31.25. Now, here's what the weird part about using the word mean. What does it mean? You know, doesn't it mean basically this, that the average of the 20 random chosen workers in New York State time travel to work was 31.25 minutes. I'll let you pause the video and copy that down. So to find and interpret the median, obviously we can see it in the chart. Median's 22.5. Remember, median's like the halfway point. You know, it's like that's about like if you lined all the digits up in order, that's the halfway point. So here's how they're going to word it on your homework. The median says about half the travel times were more than whatever this number was, 22.5 minutes, and about half were less. Because that's the median, he's right there in the middle. You can say about half the travel times were more than 22.5 minutes, and about half were less. Get the recording going. Then it says, find and interpret the mode. Would you believe in this chart? Oh, no, there is no mode. You have to read the dot plot. Which one showed up the most in the dot plot? Like, where's the highest dots? 15, right? You see that that's the highest dot. So, like, we'll say, like, a travel time of 15 minutes occurred the most. A travel time of 15 minutes occurred the most. Travel time of 15 minutes occurred the most. Let's do something that we dominate. At least I feel we're dominating. Describe the shape of this graph. Here you go. There's that graph. How would you describe the shape of that graph? skewed right, for sure. I like that. Let's talk about gaps. Are there any gaps? Like one gap, two gaps, a lot of gaps. What do you think? I'd say there's probably three gaps, so we'll say many gaps. Are we okay with that? And then here's the other thing. Do you think any of these feel like outliers? You know, is there any number on the list that you would guess until we have that as an outlier? What do you think? I agree. I think so. So let's do that. That's skewed right, has many gaps, and then there's a possible outlier at 85. I don't know if it's Wednesday or if it's Friday. We're going to be able to figure out like the math to tell if that's an outlier or not, you know, but it's coming up this chapter. So it's skewed right, there's many gaps, and possible outlier at 85. I think we are dominating that guy. And now, until we learn more to do part E, I just want to know your opinion. Out of all of these, boom, 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 the mean, the median, and the mode, which one of those, discussed with a neighbor, do you think fit this data the best? We feel that the median was the best, and we'll learn here in a second if that was correct or not correct. So keeping that app open, we're going to fill out this chart going down. Here's some symmetrical looking graphs, and here's a fact, dude. If your graph is roughly symmetric, the mean, median, and mode are all going to be basically in the same spot in the graph, you know? And so it says the mean, median, and mode will all be about equal. We'll fill that in right there, all about equal. And if you have a symmetric graph, what you're going to need is, let's just use the mean for the best measure of center. We'll use the mean. This chart is going to totally dominate your homework, by the way. So ask questions if you have any, right? This chart is going to answer a bunch of homework questions. So when you have a symmetric graph, we're going to use the mean. Check this guy out. Isn't he totally skewed right in this? So typically, there's going to be a lot of homework questions about this. The mean, how does it relate to the median? Do you remember this symbol from way back in algebra? That's the greater than symbol. You know, you might even want to like put this as a helper, because I know from teaching math for many years, a lot of students aren't sure if that's a greater than or a less than sign, but that's the greater than sign. Typically, the mean is bigger than the median when the graph is skewed to the right, so the best measure of center will be the median. We'll use the guy in the middle. This guy will represent the data the best out of those, because the mean's all messed up by this outlier. Skewed left, the mean is less than the median, but still the best measure of center is the median. Anytime the data is skewed, the best measure of center is the median. When you have skewed data, the median's going to be the best. And then here's a weird graph that we haven't really seen much, where, would you agree, it's got these two humps? That's the bimodal. So the best measure is going to be the mode, the one that occurs the most. And there's like two modes, you know, right there. So that one would be the best, because the mean and the median just is so low. It's like, no, there's high data over here and high data over there, and the mean and the median just is all messed up. So we'll use the mode. Cool. So let's move to this guy. Let's see if I need to enter this into my applet or not. First, it's the weight in grams of 12 carrots in a single bag from a local grocery store are listed here. If I want to enter this stuff into the applet, they're going to ask me to find the mean and the median and stuff like that. You see how they're asking me to do that down here? So why don't we grab our computer. Let's go back, and you can just clear that data out from where we were before. So the way you can do that, you can probably find it before I get there, is to reset the simulation. If you scroll down, just totally reset it, and then re-enter the data in. Come on, maybe. If that don't work, you can just go, right up here. It's underneath the data, reset everything. So hit OK. And then just type all those numbers in. You guys can describe the shape of the graph now. Kind of a weird one. I'll do this. Describe the shape of that graph. That guy's skewed right. got a little bit of a skew going to the right, and he's got a single peak. So finding the mean and the median, it was right here in your summary statistics. So we'll jot that down. The mean is 50.5 grams. So an average carrot in that bag from the grocery store was 50.5 grams. And then the median, like if they ranked all the carrots in order from lowest weight to highest weight, was 49.5. Which measure of center best represents the data? So that's going back to the front page of this. It's all about how we described it. Is this symmetric or is it skewed? What do you think? How did we describe this guy? Symmetric or skewed? We did it as skewed. So look back to the front page, like with all these guys on it. And on all the skewed ones, I don't care if it's skewed right or skewed left, what's the best measure of center? The median, baby. The median. Anytime the graph is skewed, we will say the median. When it says explain, it's like because the data is skewed. Data is skewed, that average is going to get thrown off by one of them outliers that's making it skewed. Cool. Here's my question. Do you feel comfortable entering this information into the applet, to where I could save a little time on some of the examples on the backs where we don't have to enter them all? Do you know where you're going? So, all right. So instead of you entering all this data, which doesn't take that long in the first place, I've done it for us. Let's just kind of check out what this is about. How many runs does Lawrence High School baseball team usually score? Here's the data of runs scored by the team in all. How many games did they play? 21. Calculate the mean. So awesome. Boom. I put it all in there. Do you see how there's my 21 games? What's our mean? 4.143. So we'll put that one right there. Calculate the mean number of runs scored. So 4.143. I'm going to go in different order. I want to do part B last, right? So I did part A, did part C next. What is the median of this data? It's right here. Our median is 3 runs. Let's describe the shape. They never asked us to do that, right, as a question, but let's describe the shape. Is it symmetric or skewed? Isn't this skewed right? So anytime you have skewed data, which value is going to be the best measure of center? The median. You guys okay with that? Now let's go back and do part B. Part B says the dot plot suggests in the game where the team scored 12 runs is a possible outlier. So they're saying, hey, this is a possible outlier. They say, what would happen if we got rid of that guy? Like if we got rid of him, would you believe we would go from 21 scores to 20? So I just go back to my applet and delete that score and do the analysis over again. And here's where we resulted. We got this guy. It says, calculate the mean number of runs scored by the team in the other 20 games. So here's the mean. Boom, 3.75. What happened to the mean when we got rid of a high outlier? Did the mean go up from what it was before? Here, what it was before, right? It was 4.143. Then it went to this. Did it go up or did it go down? When you got rid of a high outlier, what will happen to your average? It'll go down. Right? So you see that the median, though, didn't change at all. Median didn't change at all. And here's our toughest word of the chapter, I think. The mean decreased while the median stayed the same, if you want to write that down. But then here's a tough word. This resistant. The resistant is a measure of center, is resistant if it isn't influenced much by extreme values. By extreme values. If, like, a number is resistant if extreme values don't affect it. And this one takes me a while to think about, too. Like, which one is resistant? So if I go back to here, you see the medians stayed the same and the means changed, right? Would you believe that that means that the median can resist a high outlier. It's like if you just add a high number to the list, it doesn't change what's going on in the middle at all, right? It didn't change the middle, the median. But the average totally changes, right? So the mean is not resistant to strong extreme values, but the median can resist those, right? That's kind of weird. So we'll try those on homework and see how we do. And then here's the last one I want you to type in. Put those numbers into the applet, please, and let's answer these questions. You can work together. So anytime they mention median, that's where you'll say about half the time, you know, because median's in the middle. Half the time Yolanda scores better than an 83 and half the time worse, or whatever order you want to do. That's what the median is all about when you interpret it. And then isn't the mean like her average score? Her average is at 82.364. Please make sure you round it the way your homework program says to round it. Like that's rounded to 3 decimal places. They might say 2 decimal places, so you got to round that. But isn't that so much nicer than having to add them all up and divide by how many there is? Like it does the work for us. All right, before I show you my averages, because on the next slide I got that summary statistics, what if Yolanda got a 0 on her next quiz? Which measure do you think this will affect more? Tell your neighbor, the mean or the median. So, yeah, it's going to throw off that average if she got a 0. So there it is. There's the summary statistics. I recalculated it for you. Just to show you, you could go back to your app and just in the data add a 0 and then begin analysis again. So you still have all your data there, but I got it. Recalculate the mean and median. So the mean is 75.5 and the median is 82.5. It did change the median just a little bit. Just a little bit. It changed that median, but not much. Didn't her average drastically change? She went from averaging like an 82 to a 75. You know, it's like, so let's see if we can fill this out. Explain why they're so different now. The blank decreases more than the blank. So we've said that already. The mean decreases more than the median. This is because the blank is resistant to outliers. Who is the resistant one, the mean or the median? Who resisted that 0? The mean, which changed a lot, or the median, which barely changed it? Who is resistant? The median is resistant. It resisted the outlier. So the median. Cool?